what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by Ranty Flat Earth and Sleeping Warrior. How are you both doing?
Doing good, thank you very much. Anthony?
He's not there. sleeping warrior.
Sleeping on the job. That's not very good.
Maybe he's got an internet problem. Anyway, how are things with you, Ranty?
All good, all good. I've literally just skipped away from work for... I've got about 15 minutes and then I have to go because I've got to take my dog to the vet as well. So, and then I'm back at work after that. So you've only got me for a short time.
Any chance? Any chance you can show us what I was desperately hoping to get shown yesterday before you did toddle off?
Let me think. Where would I have all that stuff? Bear with me. Give me a second to find it.
Yeah, no worries.
While he's finding it, do you want me to deal with... I'd like to show something that puts this science fiction that's currently being not presented, but asserted by one particular person into context. At the end of the show yesterday, the second show, Arwin made a concession. His concession is that he no longer accepts, or he no longer pushes the downward acceleration force. Rather, he now claims, my position was just drop the word force at the end of it. But now, instead of dropping the word force, he now asserts that there is an upwards acceleration effect that has no cause, because he admits and accepts that we are not moving upwards, but he claims that there's now an effect that would be caused by something that should be us moving upwards, but is not us moving upwards, but we have the effect of it anyway, which I find ridiculous. But because it was right at the very end of the show yesterday, Nathan rounded out immediately as it was being said. So I'd like to present something to try and clarify this nonsense position, and it should take me 3 minutes.
Given Ranty's limited time, I was about to say no. How long do you need,
Okay.
Ranty? Are you still?
I don't mind waiting. I don't know how long. I'll wait for Ranty to finish if you want.
Okay.
Just he finds it.
Yeah.
I think I'm ready. Hang on.
Yeah,
just let me
you
get
go
the
first,
video.
Ranty. Then we've got a short summary before any housekeeping of what's going to get covered in detail on this particular debate by you two, and then we can move on to you, and then hopefully we'll get some more guests in. Hi, Mark. Hi, Travis. How you doing?
Hello, gentlemen.
Hello.
Right, you're up and presenting, Ranty.
Okay, so when I went to Wales, I drove to Wales to go and do some observations there. I was very confident that I'd seen the Isle of Man. Now, as you can see, it's very, how can I say, hazy.
Can I just say that, Ranty? I don't mean to interrupt, but for the American audience, Wales is a completely different country. It's not a city. It's a country.
I drove to a different country to go and do these observations.
I did not know that.
Yeah.
So anyway, I did it. It was a 5.5 mile round trip. I got there. I was filming the wind turbines, and then I noticed this landmass, and I could see it with my eyes. And the camera really struggled to get it. I'll be honest. I wasn't even sure if it was capturing it. But I was extremely pleased that there was enough in it to be able to grab some images out of it, and it's absolutely stunning. You probably won't see it too well on this. Although you can actually make out the mountains here going across there. I do zoom in a moment. And what I've figured is that we're seeing down to approximately 200 feet. The curve calcs, if you believe in the curve calcs, Nathan hates them, but the curve calcs would say 1,400 feet should be missing, right? And essentially we're seeing the whole of the northern part of the Isle of Man. We also do see the southern part in the early part of the video, but I didn't focus on that too much, like I said. So the video's up. I think I might actually have the other video, Isle of Man from Wales, where I do apply some filters on it. So let's get rid of that. Hopefully you can see it now as I zoom in. Can you see this land mass here where my cursor is?
If I can see it on my blurred out projector, then it's visible. I can definitely see it, so yes.
So I'll just I'll let it scroll in a bit more. And yeah, this is definitely the Isle of Man. No two ways about it. You can clearly make out the land mass here. So I've got them all written down anyway. This is a video I uploaded onto my own channel. I might have something here that we can have a look at. Yeah, so this is some screenshots that I took of the through the video, and you can see the land mass where I've been able to bring out the land mass and all the individual range of mountains and stuff. We have Snaefell, which is obviously this one here, Claygoer, North Barul, which is here, and in a couple of images time, I should have one where I've put a ruler in and I was able to, here we go. Yeah, so I was basically able to, the Greba mountain range, which is here at 1,385 feet. Snaefell is here at 2,037, etc. And all these different things here, measurements here. I put the ruler in and I essentially worked out, and I worked it to feet. So we've got 2,037 for the height of Snaefell and 1,385 for the height of the Greba Mountains. And when we look down to the hard horizon, what we see is the hard horizon, we're down to around about 200 feet, 220 feet or so. Now, bear in mind that the curve calcs say that where this line is here, this 1,400 feet, that's what should have been missing. So it was absolutely stunning to actually just capture that on the hop. So I'm looking forward to be able to getting the P900 adjusted so that we can see through this kind of stuff, and maybe get a couple of filters for the P1000 as well, because I've heard that polarized filters will be able to help peer through this mist. And if we can do that next time I go there, if this island pops up again, if the Isle of Man pops up again, we should be able to see through all this and see it in much better detail.
Can you show us on Google Maps where you were in Wales?
I can.
Mark, you're very quiet.
So when we come down here and we go over to Llandudno, so go over to Llandudno here, we have essentially a windy path. You've got the path that goes down to the lighthouse, and you've got the path that goes up to this like cafe that's up here. So from this location down here, right next to the house down at the bottom here, this is where I was filming from. And so if I put a line of sight in from there, and then we come over and we're looking at the Isle of Man. So turn this around a section a tad. We're looking over at the Isle of Man, and we come down here, we've got North Barul, etc. So you're looking at this sort of distance, we're looking at 69 miles, 68 miles or so. Then we do see a gap. There's definitely a gap in the video. And at the start of the video, you do actually get these mountain ranges. They are seen, but it's only briefly. I've not been able to get much data out of that, unfortunately. But yeah, so these mountain ranges are captured too. So, and down to 200 feet. So curve calcs say 1,400 feet should be missing. And that's not what we're seeing.
Absolutely awesome. Can you stick the picture back up? I'll just stick it back on the on nice and big once more.
Which one do you want? Do you want
no.
Let me go back.
Yeah.
This one?
No, the raw, either still or footage itself.
How's that?
Pretty good. Pretty good.
Yeah, so that's what I was able to bring out, yeah.
I saw a video online recently with a Fuji camera, and its main attribute, I don't know what zoom it had, but its main attribute was to see through fog, mist, and atmospheric conditions. I'm going to have to refind it and find out what that camera was, but it was made by Fuji.
Well, I think we need to, look into this because we do have a lot of difficulty looking across a lot of ocean. That's one thing we do find is that we do encounter this mist. If there's any kind of optical things that can help us to see through that, then it's going to make things a lot easier when we do these observations, because clearly the Isle of Man is visible, but to the average, well, not the average, to the troll in the chats and stuff, and to your average ball earther, they're going to say that this evidence is not clear enough for them. It's clear enough for me because it's absolutely undeniable what we're looking at. But to them, they can always argue that because it's not very clear, it's just to be binned, even though you can see it.
Yeah, that was my biggest disappointment in California was the cloud bank. There were a number of islands I could have shot at 20 miles, but
Anthony, can you leave your microphone alone?
Sorry.
So yeah, this is what I wanted to show. I wanted to show this yesterday and say that I had travelled. It took me 5.5 hours all in to go there and back, and I also stopped at Hoy Lake too, and I saw Blackpool Tower. I do have an image of that as well, but it's not too clear, unfortunately. Again, we've got these optics that are causing havoc with us. So if I go up top and look at this image, so again, we've got, obviously that's Blackpool Tower. You can clearly make out that that is Blackpool Tower. I think the curve calcs at this particular junction say that, like, there's where the curve calc should be. So just the very top of it, the sort of like bell at the top, you should see. But of course, we're seeing all down to the stem. It's very consistent with the time that we went and we saw it at night time, the very first time me and Anthony actually met to do an observation. Here's another one. There it is. Not very clear, but definitely the Blackpool Tower.
Awesome.
Indeedy.
Is that you? Is that it? Are you done?
I'm pretty much done. Yeah, that should not be seen in the spear. This line that I'm putting in here, basically that's the curve calcs where there. So all this additional land at the bottom here, all this part of the Blackpool Tower, this probably 200 feet or 250 feet of the tower itself should be behind the curve, and it's not.
Now, there's two things to say there. One, that validates my original observation, and two, the claim of the theodolite can measure the radius of the Earth. Where's the horizon on this picture, gents? Especially Rumpus. Where is the horizon?
Yeah, exactly.
Superb. Well done. Thank you very much for presenting all that, Ranty. I really appreciate it.
No problem. No problem.
Let's go through some housekeeping whilst Mark Dox is in.
Is that so? Just please stop touching your mic.
Sorry.
So, any signs of curvature going by what Ranty's shown? I think the answer will probably be no.
No curvature.
Nope.
Axial rotation?
No.
On the car?
No.
Every time. I've got to do it every time, haven't I? Earth, specifically presupposed spherical Earth-based rotation, Anthony.
Well, in that case, no.
Nope.
Fair enough. Pressurized system next to a vacuum?
No.
No. Struggling.
Any signs of a self-perpetuating molten iron core at the centre of, again, a presupposed spherical Earth?
No.
You do make things tricky, don't you? No.
What about the presupposition itself? Any signs of radius? R, gentlemen. Any signs of R?
Nope.
No.
What about Bill? What's his name?
Oh, Bill Miller.
Bill Miller. Any signs of Bill Miller?
Any evidence of Bill Miller? Nope. No evidence whatsoever of Bill Miller. For those that are not aware, it's the George Natanuke argument recently.
What about gravity? Any signs of that?
Oh, I don't know. Mark's got a claim on gravity. What was that, Mark? You were just about to say.
Are you going to bully me?
Oh yes.
Are you going to allow me to have an opinion? That doesn't
You can have
matter
an
your
opinion, yeah, but as long as you've got evidence to support your opinion, otherwise it's just a story.
Well, you know what I go by is what's observable.
Right.
Right, well, hang on, guys. I'm going to bail. I'm going to leave. I've got to take my dog to the vet. So
Okay.
I
All right,
will
ladies.
leave you all to it and have fun. I'll watch it back later.
Thank you very
Okay.
much, Ranty. Hopefully, Anthony, you've laid the foundation. So let's just have a bit of an uninterrupted mark.
What? What I observe is a downward force. I feel,
Force.
I feel weight. Yeah, I'm going to use the word force. You know what I mean? I'm not contradicting the flat Earth, globe Earth debate. We're both lighting the same candle, singing from the same hymn sheet.
Right, but you're using the word force, which was the point that we had with Arwen. I agree that we can have, and I say loosely, a downward acceleration, but the word force requires there's something to be causing it.
Okay.
So when you say you rely on what you observe, what's the force that you observe?
I don't know. I observe it, but I don't know. I haven't got to the bottom of it.
So
Listen,
you
I'm
don't
not.
observe it then. Right,
Say
let me
me-
make a presentation, and you can tell me where I go wrong. Then
No, listen. I'm not going to get into an argument with you personally. I know where you
no,
stand.
it's not
You know where I
personal.
stand.
It's not personal. It's on this application of the word force that I take issue with, because a force requires a push or a pull, and to be something against another body that does that. There needs
Do
to be.
you, do you agree with that? That's what force is.
Yeah,
Yeah.
there has to be.
So will you explain to me magnetic force as far as you can understand it?
Well, it needs a magnet for starters.
Yeah. Okay. Magnet
If you
piece.
don't have a magnet, then you haven't got a magnetic force.
Okay. So you use the word force then, don't you?
Yeah, but
I mean,
it's
magnetism.
subject to and conditional upon the magnet being there. But if there's no magnet there, then you have a problem.
No, we're talking about force, aren't we? Magnetic force. There is a such thing as a magnetic force.
That's right.
It's observable. It cannot be explained, though.
Well, some people try, but okay, I'll accept that point.
Yeah, it's the same with light. Light can be a force as well, but it
Really?
can't be explained.
How can light be a force? What can it affect?
Okay, let me remove light from it. I didn't think that one through. Let's stick with the magnetism.
Okay, magnets, right? So let's just say we have a magnetic force, right? But you don't know where it's coming from, and you can't ascertain that it's even a magnet that's causing it. If there's no magnet, how do you know it is a magnet?
I don't get the question.
No,
All
you
right, how
can't.
do you know
Hold on, you can't just tie him up in that many stipulations. That's like.
All right. It might be better if I made it. Let me do my presentation first, and then I think it'll be really clear.
Right, go ahead.
I think it'll be really clear once I do this, because I don't think there'll be any ambiguity at the end of it if I do this.
What's the punchline before you start it? Where are you leading me to?
I don't want a punchline. I want to show you the facts, and I will conclude comprehensively that there is no force required, nor necessary, or can be evidenced. Now, if the argument against this will be that there is a force, then present it. Let's see where that force is.
Well, listen. You're creating this scenario. I'm not particularly interested in arguing with you on what force is.
But then you can drop the word force at the end of the downward acceleration, and it wouldn't meet you.
You're not going to tell me what words I can use or not use.
But I'm going to call you out on it if you use the word force.
Okay, fair enough. So you're a Liverpool supporter. What do you know?
Yeah, what do you know?
You're a bitter.
Anyway,
We're reducing the conversation down.
Let's not let this descend. Come on,
personal
let's not let it descend. Let's just crack on.
Show us your presentation.
Right, present screen, Nath. Right, this is my position with regards to Arwen at the moment.
No, listen. This is not. I have nothing to do with Arwen's complex description of what he's telling me.
No, I know this is not aimed at you. This is aimed at my position overall with regards to Arwen's position on this force.
But way to get your disclaimers in there, Mark. Love it.
I'm distancing you, Mark. It's fine. Don't worry. My position right now is it makes me feel sick that Arwen talks about this force, but can't show no force. So I left the group chat that I was part of because I don't want to be associated with it. You can't claim there's a force if there isn't one. And I love his retort back. He hopes that I get better. Okay. So here's what we're going to do. I'm going to show snippets from a video. Now this is an anvil. You familiar with these? I'm not sure if they're made of steel or iron. Do you know what they're made of?
I would assume it's iron.
I think they might be a composite. They could be steel or iron, but I'm not sure exactly what they are. But it doesn't really matter for the purposes of this. But we know that these things are heavy. Mm-hmm. But imagine that this, you didn't know that this was heavy because you'd never seen one before and you didn't know what it was.
Okay.
And you were asked to describe the properties of this material based on what you're about to see. So you didn't have any preconceptions of what this was, but you were asked to describe it based on what you see. Now, what I'm going to do is I'm going to talk about the liquid that it's going into, which is mercury. And on screen, I've got the density value of mercury, and its density value is 13.5 grams per cubic centimeter. That's for the liquid, okay?
Mm-hmm.
Now, with regards to the metal, I've assumed it was some form of steel. It might be iron, but it doesn't matter because the value is less, and that's the point we're trying to make. But it's in kilograms per meter cubed. So what we need to do is convert that into its same units, which is what I was talking about yesterday, the units of measurements or quantification. And we see that it's 8.05 grams per centimeter cubed. So what that allows us to do now is quantify, and I should do it here. We know that the liquid has got a density value of 13.5, and we know that the metal has got a value of around about 8.05. Now, if you'd never seen this object before and you were told these density values, then you could make a prediction based on knowing what the density values were, which is what I was saying yesterday. If you reduce these down into a numerical form so that you can quantify what the physics will be, you can make a prediction based on this, and you can say, well, the 13 is greater than 8, so the 8 should rise to the top, right? But we know that this is heavy, right? So what we're going to do now is play the video, and I'll take the numbers off. And now when you get this heavy anvil and it floats, now my position is that the two forces that are in play here are density over buoyancy. The density of the liquid is greater than the buoyancy, or the density of the liquid is greater than the density of the metal. So the metal effectively floats. But we all know that the metal's heavy. So if you didn't know that the metal was heavy and had no preconceptions whatsoever, but you just saw these numbers on screen and said, make a prediction of what will happen, your prediction would be, well, if the density of the metal is less than the density of the liquid, it should float. But because everybody knows that metal's heavy, most people would go, well, it's going to sink, isn't it? But we know that that didn't happen because you've just seen that it floated. But it defies the logic that you all know that these things are heavy and it should really have sank. But it didn't sink. It floated. And I'll just play a little bit more of it because Nathan's a bit conscious about how much of this I play. Basically, he pushes it underneath the surface. It breaks, it breaches, it goes submerged. And then he lets go of it and it breaches the surface and then repels the water, the liquid off it.
Mm-hmm.
Now, that the only two values that you need in this to know and explain absolutely what's going on, comprehensively what's going on, is the two values that's on screen. The density value of the liquid that the thing sat in, and the density value of the thing that sat in the liquid. And on these two values, you can tell which what the thing is going to do. Because really, everyone really knows that this should sink. But it
there's
didn't.
no other
floated.
parameters. There's no other parameters that need to be taken into account. Is that
Correct.
what you're saying?
Correct.
Okay, so what about the pressure of the mercury on the side of the container that it's in?
Is it relevant to whether it's buoyant or not in this example?
I'm just saying there's another parameter there. You're just telling me there's
is it
only
relevant
buoyancy
though?
and
I mean,
density.
you could argue about how much infrared radiation comes from the sun, but is it relevant to the observation?
If you shifted the sides of the container or opened a little hole, then the anvil will go down to the floor because the mercury has leaked out.
Say that again. You were a bit quiet.
If you opened a little trapdoor in the container and allowed the mercury to spill out, the anvil will then go to the bottom of the container.
No, what you mean when it runs out? When it runs?
Yes.
Yeah, but that's not testing the density over the buoyancy.
So so let's not, if we don't open the door, there is a pressure going on inside that's keeping the anvil up.
No.
All right, okay.
What's keeping the anvil up, which isn't up in this case, it's more buoyant than.
So you're concentrating on the anvil, but there's also the mercury involved in there as well.
There's only two factors that influence it. It's the
what's
state.
Keeping the mercury inside the container.
Is that relevant to the observation?
Well, yes, it is. It is relevant to the observation, yeah, because if it wasn't in the container, you wouldn't have an experiment.
Right, my position is clear. There are two variables in this. There's the variable of the liquid that the thing sits in, and then there's the variable of the thing that's sitting in the liquid, and it's the relationship that coexists between the two.
And when he pushed it down, pushed it down with his arms, that was a force being applied to it, wasn't it?
Correct. So
right,
that would effectively force it down, but you can see that his hand is pushing it, right?
Okay. But what about the force that I feel as I'm sitting in my chair? There's a downward force, and that downward force, and I'm not going to make any apologies for it, is gravitational pull.
Right.
It's
Firstly,
not just,
there's
it's
two
not
things
just,
to that.
hang on. It's not just density and buoyancy. There is also a downward force.
Right. There's two things to that. Right. This gravitational pull of which you speak is not the current definition for gravity anyway. You understand that? You're talking about a Newtonian principle of gravity that's not actually current science.
I'm talking about what I observe.
Right. Well, what you observe is that you've got a density value of a figure. We'll give you the density value, like the anvil, of 8.05. But instead of being sat in a liquid that's got a value of 13.56, you're sat in a value that's like 1.3, for example, because that's the air that you're sat on. So you're going to displace the air that's below you because you're heavier than it.
If you were to apply another variable to this, if you freeze mercury, it would become a solid at some point. And
yeah, but then it physically can't move then, can it?
No, it can't. That's the same with my ass sitting on my chair.
Indeed. But if your chair wasn't there, you would fall to the floor, would you not?
Why would I do that?
Because your mass is greater than the air, which is often referred to as...
Why would I fall down? Why not up or to the left or the right or forward?
Because your mass is greater than the environment in which you're in.
So why do I not go left then?
The same reason why the anvil doesn't go left.
Yes, because there's a downward force and it's called gravity.
No, because the only thing that's in play is the density over the
no,
two.
That's what you're saying. You're saying that, but I can observe a downward force.
Right, and I only observe a downward force when his hand pushes down on it. Watch. When his hand pushes down on it, there's the force.
Yeah, okay. He increases an existing force that's already there.
Right, but that's what you're arguing with gravity.
Yeah, because I observe it and I feel it.
But there's no hand pushing down. There's no gravity pushing down.
But there is an attraction that keeps me on terra firma. I wouldn't be able to walk or run if I didn't have that grip between my boots and the ground.
You would, because your own mass is what is... Right, the atmosphere is often described as a liquid, right? I know it's a gas, but people often refer to it as a liquid. Now, in the atmosphere, be it gas or liquid, your density is greater than the gas or the liquid of the air in which you're stood. So you will displace it in the exact same way that the anvil will fall to the bottom of a swimming pool.
And what causes the grip with my boots and the concrete so that I can actually walk?
What causes the grip?
Yeah.
Your density, your own mass pushing down on the rubber that makes the shoe touch the floor, your density.
Okay, and so give me your conclusion.
There are only two factors involved. There are not any more. If there are more, then evidence is required for the third factor or other factors, because as on screen right now, the only two factors in this experiment or this observation is the value of 13, which is greater than the value of 8, so the anvil floats.
As well as the temperature, otherwise you wouldn't have a liquid, would you? You've got it at room temperature.
Well, it's a constant in this observation, so it matters not. You could argue that the infrared radiation from the sun or the gravitational pull from Pluto are also effect factors.
Listen, we can see an effect of a magnet pushing another magnet away from it. We can see that effect.
Yeah, but we can also see the magnet that does it.
But we can't explain it. We can't explain what it's doing. We can't.
It doesn't matter about explaining it. The fact is that the other magnet is there to be able to demonstrate the force.
You observe it. You observe it.
No, you need the magnet to have it.
If you all right, let's take a piece of iron, and that's a small piece of iron, and you start to push a magnet towards it. At some point,
you have the magnet doing it. But you're trying to tell me that gravity exists without the magnet pushing it.
I'm not going to say that. At some point, the magnetic force will pull the metal towards the magnet and it'll stick to it.
Right, and if you haven't got the magnet to create that effect, what's going to happen?
You can create a magnetic force from a piece of copper wire, you can't see it.
But then the copper wire would be the force. That would be the thing that's causing the effect.
It would be the electric going through the copper wire.
Well, whatever, either or, both. But the point is, you have the thing. You know the force is there, right? You can't argue that there's a force unless you can prove that there's a magnet or a copper wire in the equation.
Yeah, the Earth is the magnet, and I'm the metal, and I feel the pull. That's the evidence. That's what I'm going by. That's what I observe, and that's my conclusion.
So the Earth's a magnet?
There's some sort of force that pulls me down, yes.
But you can't show force. You can't even show this force, this downward force that you're claiming.
Listen,
You
if you
can't
go-
even show that it exists, let alone that there's something doing it.
Listen, Sunshine, if you are in a boxing ring and somebody
Don't call me Sunshine Moonlight.
if somebody slams you and knocks you out, you will fall to the ground. That's observable.
Right, that's because your density of 8.05 is greater than the 0.6 that is the atmosphere that you're studying.
Okay, listen, I finished with the conversation. We've been going on this for about a week now, haven't we? You haven't shifted, and I haven't shifted.
But I don't see how you can hold your position without something to support your position.
Listen, you're being a bit of a Nazi here.
I'm not
Insisting on what I
you
you are insisting on what I should believe.
No, I'm not. I'm saying that if you're going to claim there's a force, you've got to show that there is something that's causing it.
And you're
now,
going
in this case, look, in this case, he pushes it down with his hand, and you see his hand. That is the force. But when you're asking for a force downward, there's no hand there. But you're claiming it's gravity. But you can't prove it, and you can't even show that there's a force. But you're claiming there's a force because there's a downward movement. Well, where's the hand that's doing it?
It's the invisible force of gravity. Just like
Right.
magnetism is invisible.
The magical wand of gravity, yeah?
Well, listen, don't you imply that I accept the whole shebang and the whole book of gravity, because I don't.
No, I'm not. What I'm
It's
saying...
only what I observe and what I feel. I observe a downward force and I feel a downward force. I've said this before. If you tread on a Lego brick in the middle of the night, because you will definitely feel that force.
That's right, because the Lego brick is pushing against you because it's a physical barrier. But again, your density value relative to the environment that you're in, the air that you're in, is much greater than the air that you're in.
We're going over the same ground. We're going over the same ground here. I've had enough. You've not shifted me, and I've not shifted you.
Well, look. First off, you're done. You're done. I will conclude the point by saying that Newtonian principles of gravity that acted at a distance as if by magic, and general relativity snapped that wand in two by showing it's the curvature of space-time that's gravitational forces, not an invisible force that's got no mechanism to do it. So if you still want to believe that there's a force there, even though it's not the current science, you're entitled to believe that. But every time you use the word force, I'm going to ask you for evidence of said force. And if you don't come back with some evidence of said force, you can't have it.
If it's observable, that's my evidence.
But what you're observing is the relative density variable between the two things. Real quick?
Yes, please. Somebody else
Please
jump in.
do.
Yeah,
hey,
save the day.
No, I'm not trying to save the day. I'm just trying to process.
Saving by the bell. Saving by the bell.
Yeah.
Listen. Don't you put any snidey little remarks because I've just backed down like you did the other day with Arwen. You had a row with Arwen, and then as the show went on, you kept referring to your little victory over Arwen. Don't be doing that with me.
Because Arwen's a child, and you're not a child.
Travis, make your point.
No, my question, Mark, to you is that let's say that you and I were isolated and grew up together. We're on an island somewhere or whatever, and we're making these observations ourselves. We're having a talk one day over a broken coconut and drinking the water. And we start talking about this, and I offer my explanation for why the coconut fell, and I have the coconut as my object to demonstrate that there's weight, and then I go through my whole basic explanation of why it fell. I'm wondering how you could offer your position without anything to refer to.
Well, I don't observe it going left, right, or up.
Right. So here, let me stop you right there, because that is an exchange that I've had numerous times with heliocentrists, and my question is, why would you ask that question? Why would you ask? Because
I observe it coming downwards. That's an observation.
No. Okay. So my point is, that's all I observe. I haven't asked, and I don't know that I would naturally think, why didn't that go to the left? Why didn't that go up? I don't know that I would ask that question. So there's something else in my mind, and this is how I've come across to the heliocentrist. I say to them, I'm not trying to say it to you, but I'm saying it to them. There is something that you are presupposing in the back of your mind that makes you say, why didn't it go to the right? Why didn't it go to the left? Why didn't it go up? I don't ask that question. because that's not what I see. We don't see things going to the right or the left ever unless they're flying.
Can I answer that? If there was something
Not really, Anthony. I want to try
Yeah,
to
it was
just
Mark he asked.
I'm just trying to understand Mark's position. My question still remains: if we were observing a coconut falling, and I used the coconut and said, "This is why it's falling because it's heavier than this," blah blah blah, and you come with your position, I don't. What's the reference? How do you explain an unseen thing that I would think of you and go, "Where? What are you talking about?"
There's an awful lot of unseen things that we cannot explain.
Yeah, but I think that's a red herring because that's not what I'm asking. Let's stick to what we're talking about. I'm trying to understand what you're saying. I really am.
Well,
So
you know for sure that I don't accept the heliocentric model.
no, that's not my issue. That's not my issue at all. I'm trying to understand how you could justify combating my explanation of why a coconut fell without anything for you to base it on. I don't know where you would get your idea. It's like here it is. Here it is. How about this? How about this? This is as ludicrous as it is, right? You said, well, actually, I think a pink unicorn farted across the island, and that's what made it fall. That's what made it fall. How would you have that evidence of a pink unicorn?
Listen, I think you're talking about red herring. Goodness me! If I hold my
No.
arm, hang on. If I hold my arm up into the air with all my muscles and then relax my muscle, my arm falls downwards. I've noticed that ever since I was a baby. It's just a natural thing
I
I've
agree.
observed.
Yeah.
And
Yeah.
if I relax my arms, they don't go up; they go down by the side. So I am making reference to what I see and what I observe. Now,
I think that you're just changing the medium from a coconut to your arm, and the question still remains in terms of
why does my arm go downwards? Why does it not stay up there without having to put the effort into keeping it up there?
No. My question isn't why does it stay up? Again, my question is, I would say my arm is heavy. My arm is heavier. When I let it go, it falls. But again, and if you can't, that's okay. I just don't understand where you would get this idea of something else pulling you.
Because I feel it. Listen, I don't feel like I'm traveling at 66,000 miles an hour, so I dismiss that.
So why isn't
I don't observe any curvature on the Earth, so I dismiss that.
I understand.
So my position on everything in life is that what I observe and draw a conclusion by what I feel as well, and I feel a downward force.
Why wouldn't you simply be comfortable with saying that the weight of your arm is what you're feeling? That's what you're feeling.
So you mean buoyancy?
It's almost like, say if I put the coconut in your hand, I would say the reason why you feel it is because it's heavy. But you would say, no, there's something pulling it into my hand. But we're talking about the same thing, but you're saying it in a way that is too mystical for me. I don't know. Maybe I need to be comfortable with mystics, but
too mystical. I can't believe you're saying that. It's what I observe.
No, yeah. I don't know.
What he's saying is, perhaps you might be mistaken that which he's calling weight as the downward acceleration force that doesn't exist anymore, and he's changed his position now.
What? Sorry? I've changed my position.
No, not you, Arwin. This downward acceleration force that was coined by Arwin doesn't exist anymore, but you're saying that there is a downward force.
It's what I observe.
Let me chime in. Let me chime in a minute. We're looking at everything in its differentiated form, right? We're happy enough to accept that we live on a flattened stationary plane, the ground beneath our feet, but we have yet to sort of describe what is going on above our heads. Most flat earthers will laugh at the thought at this stage of empty, infinite vacuumous space, but we haven't filled in the gap. So we need to start defining or trying to define the confines of this earth as a whole. I agree with Mark here, and I agree with Arwin. We are under a gravity force, which is everything is reversed. It's a pushing force, and it's a reactionary force for me as a result of the electromagnetic force that is holding back the waters beyond. How can you prove this? That's a different matter. I mean, everything isn't all about scientific proof. We have to sort of extend beyond that to some degree. But Anthony and Plain Truth, I think you're looking at things in that differentiated state, and you're not asking or seeing the sort of the bigger pictures. And as I said, trying to describe the confines of the system as a whole that we're in. That's my point of view.
Thank you.
Yeah, it's an interesting situation. I mean,
Hello.
I am not
James. Hi, Jimbo.
tracking. I'm not tracking with what where you're coming from on that one, Pete. But that's okay. I understand glitches in my thought process, and if I'm not catching something, then that's the issue. It's not the.
Yeah, can I just state that I am more than happy to be shown to be wrong on this gravitational force of attraction thing. However, I'm empirical, and if that is the claim, I want to see the proof that it's true, which is the reason why I'm a flat earther, because if they claim that we're on a sphere but can't prove sphericity, then there's an issue for me. But if they're also claiming gravity, oh, here we go.
You are completely wrong. Absolutely, 100%, totally.
Show your face, Rumpus. Show your face, clown.
No, this is a conversation that.
Have we all been sniped?
No, I hope not.
No, I don't think so.
No, everything went very quiet then.
It did.
Is the Rumpus still there, yeah?
No, I'm still here, amazingly. I'm still here. Yes, Riley hasn't sniped me, amazingly.
Oh, well, but listen, before you snipe him,
I've never sniped anyone.
did you hear my position?
Yeah, Mark, you're absolutely right. You're absolutely right. You've got a phenomenon, you've observed a force, and you
What's
said
the
there's a
phenomenon?
force there. The force.
But you haven't observed the apple
Have you
grow in the
interrupted
tree.
me?
Hold on, give him 5 seconds.
Grows up in the air. You know, magic makes them
my
fall.
sentence.
Jimbo, please.
Please let
me
Rumpus
my
finish his sentence. Please let him finish.
Right.
Please.
Go ahead,
please.
Rumpus.
Right, Mark has
Yes.
observed a phenomenon. So if you put a scales, for instance, he noticed that if he gets on some scales, the scales are a force meter. They measure force. He notices when he gets onto them, there's a force there. He also notices he feels that on his muscles and things. There's a force acting on them. And he's got
Scales don't measure
hold on. He's got experimental data with scales that he can observe a force registered by a force meter. That needs explaining. So he's absolutely 100% right. It only acts in one direction, doesn't act left or right or up. It just acts down. And Mark has got a phenomenon. He's got a means of measuring it, and he's absolutely correct. So Riley, who goes on about having to explain...
Hold on, Rumpus, hold on. Rumpus, hold on, Rumpus, please. Rumpus, hold on, Jimbo. Right, you've made your assertions. Before you start representing what Anthony's got to say about it, you've been asked, what's the phenomena?
The phenomenon is the registration
Hi,
on the
P.
force meter of scales.
Sorry, I missed that, sorry. I was saying hello to P. Mars, sorry. Say that again.
Right. The phenomena is the registration on the force meter, which is the scales, of the force that it is measuring.
That's
That
not a
is the
naturally
phenomena.
observed phenomena. You're getting on a man-made piece of equipment. So that's not a natural
So
phenomena.
what?
Well, it's not a natural phenomena.
Okay, you could stand on various sorts of tomatoes if you
Sorry,
like.
we
with
are
different
in
things.
science, Rumpus. Hold on.
No, it
Can I just
measures
respond?
force,
Can
you're
I
wrong.
respond, or are you
Don't
going to talk
understand.
continually? We observe the natural world, not man-made scales. That's not
That's
an observed
irrelevant.
phenomena.
Stupid
If you're
point.
trying to
Stupid
be
point.
scientific and observe the natural world, a scale is not that,
No, the
Rumpus.
science is about observing the physical world, and observing forces with a force meter is perfectly valid. Are you saying you're ignoring
Sorry, you're
scales? You don't think
presupposing
they're a
the
valid way of measuring
cause.
things?
We are asking for the phenomena, not the measuring tool, the phenomena. And you're saying the measuring tool is the phenomena. No, it isn't.
No, I'm not. No, I'm not. No, I'm
So
not.
what's
I'm
the
saying
phenomena
measures
again?
phenomena.
What's the phenomena?
Rumpus, try again, but don't use the scales.
Well, no, scales are fine. They're a force measuring device.
So the scales are the phenomena.
No, they're not.
Well, tell me
use
what
a
the phenomena
coconut
is
in
then.
your hand.
Hold on,
The
Jimbo.
measurement of the phenomena, yes. If you want, it's not actually the cause of the phenomena or anything. It's just simply the means of measuring it.
No, the phenomena is the effect, Rumpus. So we are trying to establish the effect. That's the
And
phenomena.
it measures that effect. It
No.
measures
It measures the effect that you're
cause, the effect,
presupposing.
measures the scale of the effect.
You're begging the question.
No, it doesn't. You're simply measuring something.
Yes, and you presuppose a force.
No, it measures force. That's what it does.
No, that's presuppositional.
No,
You're
no,
measuring the weight with a man-made tool. You have no man-made phenomena. The effect of what happens to a scale is not an observed phenomena.
Of course, it's an observer. I can observe it, you idiot.
You're observing what happens on a scale, right? A measuring device for weight. And then you're attributing a cause, which is gravity.
No, I'm not.
Yes,
Not
you
yet.
are.
That's the second stage. The first stage is to observe the phenomena. And the phenomena is a force measuring device called scales, measures a force. So there's a force there. So that's job number
Okay,
one.
no
That's
problem.
scale
Hold on,
measures
hold
a
on,
phenomena.
hold on, everybody. Hold on. So can you put that into a hypothesis for me, please?
No, hang on, Nathan.
No, don't hang on. Hold on, please. I'd like Rumpus to formulate that into a hypothesis. Please.
Right. The effect, the dependent variable, is the measuring, which is returned by the measuring device of the scales.
So let me just get this correct. Hold on, one step at a time. So the observed phenomena is scales. So
it's the value that the scale.
So if something then scales, that's the effect.
No, the number the scales returns.
Sorry, so the number on a man-made device is your observed phenomena.
Correct.
This is nonsense. We're talking about the natural world, not a device made by man. Look at what science is. Look at what the natural world is. You are a buffoon. This is not an observed phenomena. Just like the Cavendish experiment also has no observed phenomena. You are simply begging the question. That is all you are doing, and then you are going to talk continually over the top of me and call me names.
I'd like to suggest an alternative phenomena. Can we just say that the phenomena is that if you drop an object, it appears to go down?
You can have that, but it's much easier to say what's the force applying to that object. So if you put it on some scales, you can actually measure
that. Fingers in your body.
That begs the question.
That you ate that picks up whatever you're dropping.
Force meter. The scales
you're ignoring yourself and releasing potential energy. There is no force.
There's no presumption of
gravity.
gravity.
It's just
there's
you
no
giving
presumption
something
of gravity.
energy.
All we're saying is, on a force meter, what do we see when we put something on a force meter? We see the force meter returning a value. That's no presupposition.
Sorry, hold on, Jimbo, hold on. Let's just hear.
There are no presuppositions at all.
Let's hear the full hypothesis then.
Returns a value.
Can you stop talking? Let's hear the full hypothesis. If what, then what?
Right. If I place something on a force meter we call scales, it will return.
Hold on. Sorry, you've now substituted the dependent variable for the independent variable. So if scales would be an independent, not a dependent variable, therefore not a phenomena. So you have substituted your independent variable for the dependent variable.
No, you got it wrong. The dependent variable...
You started by saying if scales. Well, that is, according to you, your phenomena. So the cause of the phenomena, the cause being the independent variable, of the phenomena, the dependent variable, which you claimed was the scales. So you have now substituted one for the other. Okay, this is a logical fallacy. You are begging the question. It is simple. We have pointed it out, and all you're going to do is talk continually over the top of me. You're now talking continually over the top of me.
But you just lied. You just lied about. I said the dependent variable was the value returned by the scales. I've never ever said anything else. And
Yes, you did. Yeah. Then you said if the value on scales. So therefore, if is your independent variable.
No, you've got confused.
No, I'm not confused. I know the difference between a dependent variable, which is the phenomena, and the independent variable, the thing you will change. And you're going to be changing something on a scale, a man-made device.
As I said before, the value on scales is the dependent variable. I've never said anything else. If you just
so a value on a scale is an observed phenomena, is it? So people go out into the world and observe values on scales, a man-made device. This is the biggest load of horse crap I've ever heard.
Yeah. Well, you're an idiot if you think that doesn't...
No, I'm not an idiot. I understand what science is, and I understand what an observed phenomena is. I understand what a phenomena is, and it absolutely, unequivocally will not include what happens on a scale, a man-made device.
Let me get this right. You do not think the measurement of the scales and the values it returns...
Give me the hypothesis again. Just give me the hypothesis in its full form.
Okay, I'll keep on trying to interrupt me. Right, here we go again. The dependent variable is the value returned by the scales. The independent variable is what I place on the scales. Is that okay? There you go. It's quite simple.
So explain the hypothesis. Give me the full hypothesis.
Right. The hypothesis is that the Earth attracts the thing you've placed.
Hold on. You're introducing new factors. You've just told me about the weight of something you put on a scale and the measurement the scale gives. Why are you now talking about Earth? We've got an independent and a dependent variable. Why are you now talking about Earth?
Well, I'm telling you I'm telling you, obviously, when you're
just stuttering. I've got your independent variable. I've got your dependent variable. Now put it into a hypothesis.
The hypothesis includes the cause. Right. So the
cause is the weight of the thing you put on the scale according to you and your buffoonery of a non-scientific hypothesis. A hypothesis is a scientific prediction. So your prediction will be what the cause is of the effect. The effect in this case being the number on a man-made scale.
Right, and the cause of the value on the man-made scale, this is irrelevant, this man-made, is the amount of mass you've placed on the scale.
So mass is your cause. Nothing to do with gravity, your independent variable. The cause is the mass.
and the attraction of it.
Excuse me, let's not talk about any other bullshit that you're now going to assert on top of your cause, which is the single independent variable, if it is to be presumed to be scientific, which it is not, because you don't have a valid observation. You don't have a valid phenomena. So your science is pseudoscience, it is nonsense, and if it was to be presumed to be true, your independent variable is mass, not gravity. You just told us.
That there's always two factors in something. So, for instance, force is equal to mass times acceleration. So you've got mass.
Yeah, you're just giving me a load of word salad, which I'm not interested in. We've gone through your hypothesis, and you have established that the cause is mass. That's what the cause is, according to your crappy, non-scientific, non-formulated correctly, non-observed phenomena scientific nonsense. It's bullshit. It's pseudoscience. It doesn't give you anything to do with gravity. You gave me the independent variable. It was mass. That's your cause, mate. Mass. That's your cause. Mass.
No, because you have two.
Oh, right. So your independent variable, the cause, in the cause and effect relationship you've described, is not the cause, right, Rumpus? According to you, it's not the cause now. Why are you talking in doublespeak, you complete buffoon? You obviously don't understand science because you're a moron.
You have two things in force times mass times is equal to...
Really? Well, in science, we have an independent variable, the thing you will manipulate as a researcher to cause the effect. And the thing that we are having to manipulate in this instance, the independent variable, is simply mass. Nothing more, nothing less, according to you. That is what we have. Mass is the independent variable.
Nathan. You have more than one variable, Nathan. We've got two here, the mass of the Earth and the mass of the object.
Oh, really? Well, in science, we have an isolated, independent variable, you complete thicko. Clearly, Rumpus doesn't understand science. Otherwise, what's going on? Why are people getting muted? Don't mute anybody. Rumpus wants to talk continually over the top of me. Eventually, you'll get kicked out.
Two things, Nathan. There's the mass of the Earth and there's the mass of the object you place on the scales.
Oh, right. So you don't have an independent variable then. You seem to have two variables. You're not capable of isolating one of those variables. Therefore, it's not science, mate. You don't have an independent variable. You've got two things at play, unfortunately. Mass and the Earth's gravitational force that you presuppose. So, unfortunately, you don't have science here, Rumpus. You have nonsense. You have word salad. And you have presupposition. All you can do is beg the question. And if you continue to just talk non-stop, I'll kick you out. So I strongly suggest you shut up or you're just going to get kicked out, Rumpus. Stop talking. You're talking absolutely continually.
I'd like to talk to Rumpus. Rumpus.
Hello.
Hi, Rumpus. Hi.
Oh.
So I'm in the same position that I was with Mark. So you and I are on an island and we're having a coconut drink and we're discussing the coconut falling from a tree.
Mm-hmm.
And we pick it up and I say, I feel the weight, this, that, and the other. This is why it fell.
So you feel a force, right? Good. Yeah.
I feel the weight of the coconut.
Weight is a force, yeah.
Okay.
Weight is not a force.
Weight is a force. Look, any definition.
Okay, hold on.
Sorry.
Hold on.
No, weight is not a force.
Weight is a force. Look at any definition you'd like to look at. Weight is a force. Mass is not.
Okay, hold on, please hold on. Let me.
Weight.
I can ask. Let me just add Rumpus. Okay, so. Weight is a force.
Correct.
Okay, so would you feel comfortable? Would you say mass is a force?
No, mass is not a force.
Okay, I just wanted to understand the clarification.
Can I ask?
People don't understand that, unfortunately.
No.
Let him finish his point.
Let me just. My question.
Do coconuts grow in trees?
Let him finish his question. Let him finish his question.
Coconuts grow in trees?
Let him finish his question.
Rumpus, you do not run this hangout. Stop rumpusing the hangout. If you do it again and tell people on this panel what to do, you'll be ejected.
Well, I'm being interrupted by some other
I don't care. I am in control of this hangout, not you. If you tell people to go ahead, I will eject you. This is my hangout. Shut your mouth.
Okay. That's fine. I'm being asked a question.
Rumpus. So you and I are having this discussion. You have to assume that we don't have any exposure to modern science. So we're just two blokes talking.
Yep. Fine.
Okay. How do you offer an alternate explanation other than the simple weight of the coconut for why it fell? Where would you get your
Well,
information?
that's correct. The weight, which is the force of gravity acting on the coconut, is
No.
its weight.
No, that's just a presupposition that you have now inserted, Rumpus. How many times do I tell you not to beg the question here?
Listen to me,
Not a
Rumpus.
an observation that the force you feel on the coconut is something you can measure observable, just like Mark was talking about. So you can start just with that, saying, I observe a force acting on the coconut. Then you try and explain why that happens. So first of all, you just simply make the phenomenal observation.
Okay,
force
ready?
acting on the coconut. Thank you.
Okay.
But I don't.
Okay.
I don't
The
observe a
coconut
force.
is- the
I don't
coconut is
observe a
heavy.
force. What's the force I'm
You can
observing?
measure it with
Sorry,
scales.
sorry. What's the force I'm observing in this coconut example? There's no scales here, is there?
Okay,
So what
use your arm. You
force?
can use your arm as scales.
Sorry, we're not looking at scales. We're looking at a coconut. Where's the
You
force?
can hold the coconut, and the force acting on your arm is the same as acting on the
Oh,
scale.
so
you
I've
can
got to
feel it.
pick the coconut up.
Well, no, you could put it on the ground. You could have the coconut rest. You could have your hand on the ground and have the coconut on your hand.
Okay, so the coconut's on the ground resting. Show me the force.
Well, if you say you want to use your arm as the force measuring device,
The
then you
coconut
obviously
is on the ground as stipulated by you. That's one of the scenarios you gave. Show me the force that we are going to measure.
You can't show force, just like you can't show pressure.
According to you, we can. We can show the phenomena of it on a scale.
Only through the effect it has. Just like you can't see wind or air, you have to have things that measure these things.
Yes, the
So you
effect
have to
would
have
be
a
the
measuring
phenomena.
device.
The effect would be the phenomena. I've got a coconut on the ground and I'm asking you to tell me what that phenomena is.
Well, if you haven't got a measuring device on it, then you're just looking at
Sorry,
it.
a coconut on the ground, Rumpus, is a concrete noun. There is no phenomena.
Well, there is. It's an observation.
An observation of a coconut is a concrete noun.
Well, if I put it on a measuring device, it will.
Sorry,
be,
if we put it on a measuring device, then we are doing something. What is the phenomena? The coconut is on the ground.
something. You're not
Stop.
doing
You're
something,
right.
you've
You're
done
getting kicked
something.
out. You're just talking over me constantly.
Get your tenses
You
right.
don't have a phenomena. You dick.
You are. You've got visual
You're
impressions.
stuttering
You've got
because you
photons.
are a
You've got
moron.
photons. You've got
Stuttering
photons in your
Rumpus.
eyes. That's a phenomenon.
Yeah, you're just talking over me non-stop. Goodbye.
He ruins every conversation, doesn't he?
No, he
I'd
comes
like
to
to
beg the
defend the
question
coconut
and
tree.
basically assert that there's a force there. I say, what's your observed phenomena? We're looking at a coconut on the ground, and he says, you can't observe a force.
Pete Shea says that gravity is a pushing force from above, not a pulling force from below. That's interesting.
Yeah.
How does a coconut get in the tree in the first place? The poor tree, it's getting neglected here. Same as apple trees. Things grow in trees above the ground. When they're ripe, guess what? If no one helps them, they only have one way to go, right? Down. It's not a magic force pulling on them. They grew in the trees in the first place. You know, we create this stuff. If I drop a mic, I drop a mic. If I put it on the scale, if I, and then we pull ourselves out of the equation like we had nothing to do with it. It's like hooking a bowling ball and feathers 40 feet off the ground and then saying, oh, gravity's pulling down on it. What about the scissor lift that was used to get the bowling ball up there in the first place? And the person that did it.
I wanted to know how many people on the panel think that scales measure force, or does everybody think that scales measure
Mass.
weight? Yeah, they measure mass.
Mass.
Yeah, not
The-
force.
the-
I've
the
never
thing
ever
that's-
heard anybody say that scales measure forces.
Yeah, the old French system was the avoir de poids system. To have weight is what it translates to. But it is a different scale, and it has a different meaning too, because again, because we've defined it better now, I believe, with mass and mass per unit volume, we don't have to worry so much about the word weight. And here's why. If you want to lose weight, go to the moon. You weigh 1/6. Your mass will not change.
So they say.
So mass is a better constant to use for
The thing
most
is, though,
things.
even if we were to concede this point, right, which we're not doing, but for the sake of discussion, let's say that we conceded the point, right? It doesn't satisfy the current scientific definition of gravity, because the current
if you
definition
ask
of gravity
me,
is bending in
it's that-
space-time.
as
It's
simple
not
as
an attractive force between masses.
we're ignoring the tree. We're seeing the coconut as if we're watching some kind of magic wand holding it there. And from the second it's released, there's a magic force pulling it down that we've created and have to analyze now. In the tree. It has no place to go once it's ripe, but down.
I'm
Same
going
with
to
a coconut.
Hold on, Jimmy.
Yeah,
Right?
but James,
Hold on,
Whatever.
Travis.
Where's
Hold
it
on,
gonna
Travis,
go?
Travis,
All that
hold on.
stored energy, a microphone in your hand. Oh, it's not body at rest anymore. You know, Newton's first law, a body at rest stays at rest. You pick up a darn microphone, guess what? It's not a body at rest anymore. Is there really a gravitational force pulling it down? And as for the other thing about this upward motion, there can't be, because if you look at that slinky drop where the extended slinky is released, if the Earth was moving up at 9.8 meters per second, whatever, it would come up to join the bottom of the slinky. And that don't happen. It stays suspended in just absolute, like, zero gravity till the top of the slinky comes down to it. So there's no upward, like flat Earth, whatever that group is, it's whatever, PSYOP,
Flat Earth Society.
Their theory that the Earth is coming up and going up at 9, that's where our so-called gravity comes from. That's nonsense too. That one demonstration of the slinky falling is sort of proof the Earth is not moving up to meet it.
James,
That's for sure.
I agree. Travis, please. I just want
Okay.
Anthony to, because Jimbo was also talking when he made this point, but this is all of what we are describing in terms of measuring the attractive forces between physical bodies. This is all Newtonian, and I just want Anthony to make his point before I round out for a quick 10-minute break.
Well, the point is that even if we concede this point about forces, which I'm not prepared to do because I want evidence that the force is there, but even if we did concede the point about it being a force, that does not prove gravity by the current science. The current science for the gravity force or the gravity thing is Einsteinian's bending of space-time. It is not Newtonian's downward acceleration force, if you want for a better phrase. So even if we did concede it, that's not proving gravity, and that's the reason why the Cavendish experiment, or one of the reasons why the Cavendish experiment, proves absolutely nothing.
And with that, I'm going to say first and foremost a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the debating panel for making this debate possible. If you hated the show, then you know exactly what to do. But if you like the show, maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!